Okay, now we are going to consider question 2 about omitted variable bias. So so the first question show that S is endogenous in the estimating equation. The estimating equation, there are two alternative ways. I think the question is not complete enough. So you may simply write it as alpha plus alpha 0 beta 0 Si plus gamma 0 Ai plus epsilon I. So you may consider all these guys as epsilon tilde, and then it is easy. Then covariance between expectation between Si epsilon I tilde is expectation of, say, delta 0 plus lambda 0 ai plus ui comma gamma ai plus epsilon I. So in this way you can write this form, or by the way, you cannot say expectation, but you have to say covariance. And then it should be variance, right? So because there is no guarantee that epsilon tilde, so we don't know whether the expected value of a is 0 or not. So epsilon tilde may not be mean 0. So then using expectation can be dangerous. So this is correct. And also I think what I did not think about was instead of a0 you may write this way: s minus delta si minus delta 0 minus ui over lambda 0. So you can replace a with this using the equation given in the question, and then it looks like this: beta 0 minus plus gamma over lambda si plus and so here, so intercept must be adjusted by this much. So plus the error term is minus gamma 0 over lambda 0 ui plus epsilon I. So this much can be also viewed as epsilon tilde. So I was not, the question was not complete enough. The question was wrong. But either way, there is nothing wrong. The question was the problem, and most of you have done well, so I don't worry too much about this. And in this case, still the idea is the same. Covariance between s and epsilon tilde is covariance between delta lambda a plus u comma minus gamma lambda u plus epsilon. So therefore it is minus gamma minus gamma over lambda sigma u squared. So I don't know what I used in, like, when I make this question. So the answer is different. That's interesting. So the answer in here and here are different, but also beta is different. The coefficient is different. Here beta includes something more, but here beta is left as beta 0. So the question does not specify the setup completely well. Therefore, then misspecification bias. Again, the same problem arises here. No. So same problem arises. In this case, beta hat can be written as y, the covariance divided by variance of s, right? There is no problem, and variance of s, so variance of, you can calculate each of them. Variance of s is variance of say delta plus lambda A plus U. So it is, because A and U are uncorrelated, lambda squared variance A plus variance of U, right? And covariance between Y and S has to use the general form, the underlying true data generating process, and delta lambda A plus U. So in this case, I'll tell you the difference. So this equation and this equation are given by the question, so there is no doubt about this. However, anyhow, epsilon tilde is something wrong. Somewhere the equation, the estimating equation is wrong at some point, and this approach is making epsilon wrong, and this approach making beta and epsilon wrong at the same time. So there is, so anyhow, we are considering a wrong equation. So there is no correctly wrong equation. Both are wrong. But from this question, this is the only correct way to show that. Anyhow, you can expand. If you expand it, then you will get the answer. So I won't derive more than this. And covariance between Y and U need to use the same approach, and you have to use the same approach. Then in the end it will have, so beta, so covariance alpha beta S plus gamma A plus epsilon comma U, and U is correlated only with S. So using that, you can find the answer easily. There is nothing special. And E, oh, this is D. This was D. C. In part C, what I expected from you was that, so C, part C, what is the expected misspecification bias, sign of the bias? Then I wanted you to use the intuition from the example. Say, suppose that the Y, so ability is affecting the education, and education affects Y, but at the same time it affects Y. So this is beta. This is the true parameter you want, but we have lambda and what is this? It's gamma. Then this is the true relationship, and of course we expect this to be positive. This is not important. This is not important. But what you have to find here is you need to think about this indirect channel. Whether this indirect channel is, this is bias. So whether this indirect channel is positive or negative. And the answer is, we expect lambda to be positive, because higher ability implies higher education. So it is easy to guess lambda. And gamma is also positive, we expect. We expect gamma to be positive because higher ability implies higher wage. So also it is quite obvious. Then obviously this channel must be positive. So in other words, so education, when you do not observe ability, there are two possibilities. Education itself increases wage, or also at the same time implying better ability, which is ability which indirectly implies increasing wage. So both increase wage as education increases. So when you get higher education, then education itself may improve your productivity, but at the same time, higher education implies you are smarter, and so that is another channel you can get better wage, but you don't want to include this in your estimation. So this is what you want, and this is the bias. So therefore the bias is positive. In any case, the intuition is positive, and it is also very clear from the equation. So lambda is positive, gamma is positive. If you accept them, then from part B, positive bias is obvious. So I wanted you to explain the intuition. So it's simple enough example, and you need to practice that kind of intuition interpretation. And the last one, E, it is so obvious. As the ratio goes to 0, bias goes to 0. But what I want you to realize here is that, remember, the ratio is signal over noise. So it is the greater the better, right? So what you want in the ideal situation, you want less noise but more signal, right? So you want like more signal. So I would expect if the ratio goes to infinity, then there is no more noise, so bias goes to 0. So this is kind of like wrong intuition. It is wrong, but I wanted you to think about this. No one wrote this in your answer, but why is it wrong? It is wrong as the noise goes to 0, and as the signal becomes more important, ability becomes more important, then the omitted variable bias becomes more severe. So what you want here is, even if noise increases, even if noise becomes more important, you want to remove the ability from your equation. So it is not ideal in some sense. You are using noise, so just you get no bias just because the noise U is uncorrelated with anything, uncorrelated with epsilon, right? So only because noise is uncorrelated with epsilon and A disappears. So variance of A goes to 0 and noise becomes larger. So this is an example where the case where you get 0 bias, but it is, of course, it is not likely, and also it is not something you want. It means that schooling is just unrelated. It is not related to the ability. Okay. Yeah, I will continue in the next one.